So this video is going to be on filling in and answering questions based on tree diagrams. Now you'll usually find that if you have a probability question near the end of the paper, it will be asking for you to do a tree diagram. So sometimes they give you the diagram out to fill in, and sometimes they give you a question where you don't have a tree diagram to fill in and you're expected to draw one yourself, but they usually give you plenty of space in order to do that. Okay, so when dealing with tree diagrams, okay, we're dealing with probabilities, so we're going to be looking at doing arithmetic with decimals and fractions. Right, so Jill and Jack are playing 2 games of cards, and the probability that Jill wins a game is 0.4. And now it's asking us to complete the probability tree diagram. Now, notice that it hasn't given you any other probabilities except that Jill wins a game. Now, there is another outcome that could happen, and that is that Jill loses a game. So what's the probability that Jill loses? Well, there are only 2 possibilities, okay, because obviously this card game you cannot draw. Okay, so the probabilities must add up to 1. So we can find out the probability that she loses by just doing 1 minus 0.4, which is 0.6. This means we can now fill in our tree diagram. So in the first game, Jill wins is 0.4. And if she loses, it is 0.6. Now in the second game, it has exactly the same probabilities. So if she wins, 0.4, she loses 0.6. Again down the bottom, if she wins, it's 0.4, and if she loses, 0.6. Now that will be sufficient to earn you 2 marks for completing the probability tree diagram. Okay, but now we're going to look at how to answer questions on these tree diagrams. Now, I would suggest before you even think about answering any questions that we do some extra work on these tree diagrams. Now, starting at the top here, we're going to work out the probability of each of these different situations occurring. Now, to get up to the top here, as you can see, we have gone up, which means she's won the first game, and gone up again, which means she's won both games. So we're just going to mark that on here by saying she has won and she's won again. So we're doing the probability of a win-win. Now, in order to work out the probability of 2 things happening, one after the other, we times the probabilities of each event. So we're going to do 0.4 times 0.4, which gives us 0.16. We're also now going to look at the one below. Now this is the probabilities that she wins first, that's why we go up, but then we go down, which means she loses the next game. So again, like above, we're going to times the probabilities, 0.4 times 0.6, which is 0.24. The one below that, we go down first, which means that she loses the first game, but she wins the second. Notice how winning and then losing and winning are seen as 2 different events here. So we times the probability, 0.6 times 0.4, and as you might expect, it's got the same probability as the one above it, 0.24. And now we're going to finish off with this one down the bottom here. Now we've gone down twice, which means that she's lost the first game and she's lost the second game. Which now means we're going to times 0.6 and 0.6 to get our answer 0.36. So at this point, there are plenty of opportunities to check our work in. Firstly, on each of these branches, you can check that these numbers add up to 1. And likewise, on this branch and this branch, you can also check that those add up to 1 as well. Now, the other thing that we can do is when we've got these probabilities at the end here, we can check whether these add up to 1, because they should also add up to 1 as well. So as you can see, we can add them all up, and they do. So we've got everything right so far. We're now ready to answer our questions. So this question says, what is the probability that Jill wins 2 games? Well, that's the probability of a win-win. And as you can see, we've already worked that out at the top. That's 0.16. Now this second question down the bottom is asking for the probability that Jill wins at least 1 game. Now that means she can either win 1 game, or, because it's at least, she could win both games. So we've got the probability of a win-win, the probability of a win-lose and a probability of a lose-win. Now, when we've got all of these different things that could happen, what we need to do is we need to add all these probabilities up. So we've got 0.16 plus 0.24 plus 0.24, and those all add together to give me 0.64. Okay, so this next question is an A-star question. Okay, it's still on tree diagrams, but it's got a very important extra point to it, and you'll see it gets a little bit more complicated because of this point. So the question's saying that I've got a bag of 3 red and 4 blue marbles. Now Ben picks 2 marbles out of the bag without replacing. And I put this without replacing in bold, and I'm going to underline it here because this is the really important thing that turns this into an A-star tree diagram question. So again, the question is exactly the same as before. It's asking us to complete the probability tree diagram. Then we've got some probability questions down the bottom. So why does this phrase, without replacing, make this question different? Well, I'm just going to demonstrate for you what is going on in this question. So as you can see, I've now got my picture of the bag with the 3 red marbles and the 4 blue marbles. And I'm just going to start off by writing down the probability as a fraction of picking a red marble out of the bag. Now, the probability of picking a red marble out of the bag is 3 out of 7. The probability of picking a blue marble out of the bag is 4 out of 7. Okay, so far so good. All right, we've got our probabilities, but what's actually happening now with this second marble? Well, if we go up the tree diagram, we can see that he's first picked out a red marble, but he hasn't replaced it. So I'm going to do that now. I'm going to take the red marble out, and you can see the number of marbles has changed, and also the amount of reds has changed. So our probabilities have changed. So instead of now being 3 out of 7 again, I've got 2 reds, and this time it's out of 6. My blues, the number has stayed the same. The number of blues has stayed the same, but this time it's out of 6 marbles. So now I'm going to look at what happens when a blue goes out. So if I remove a blue and I go down my tree diagram, okay, you'll see that again, the amount of marbles has changed, so there are now only 6 in the bag, and this time the amount of blues has gone down by 1. So looking at that, I've got 3 red marbles, but again, it's out of 6. And this time, instead of 4 blues there now, I've only got 3 out of 6. So in summary, this without replacing means that you've got to be really careful when writing your second sets of probabilities. You need to think about what's happened, what's happening to the different amounts, and make sure that you're writing these probabilities very, very carefully. Okay, so now we're going to complete the question exactly the same as we did in the last section. So the top, the probability is that he's picked a red and a red. We're going to multiply 3/7 by 2/6, which gives us 6/42. The next one, we've got the probability of a red first, then a blue, and this time we're going to be multiplying 3/7 by 4/6, and that gives us 12/42. We're now going to do the probability of blue then red, and this time we've got 4/7 multiplied by 3/6, which is 12/42. And finally, we've got the probability of blue, which is 4/7 multiplied by 3/6, which is 12/42. Now again, just like we did in the last question, we're just going to double check that all of this is right. So these two need to add up to 1, and 3/7 and 4/7 is 7/7, which is the same as a whole, so that's fine. 2/6 and 4/6 add up to 6/6, which is a whole, that's fine. And 3/6 and 3/6 also add up to 6/6, which is a whole, and that's fine too. Okay, we're now going to look at these as well. So what we're wanting is we're wanting the 6, the 12, the 12, and the 12 to add up to 42, which they do. And that gives us 42 over 42, which is also 1. So all of our checks are done. We're happy with all of our numbers here. Now, some of you might have noticed that throughout this entire question, I haven't simplified a single fraction. Now, there's a good reason for this. Firstly, it makes my timesing at the end a lot easier because I will know after I've worked out the first 42, I know that every other denominator after that will also be 42. The second thing is, if you notice in the last question, there was times where we had to add up probabilities. And if you remember, fractions can only be added when they have the same denominator. So not simplifying throughout means that our adding at the end is a lot easier. So let's answer some of these questions. So answering these questions down the bottom, just like we did before, what is the probability that Ben selects 2 blue marbles? We've already done that. The probability of blue and blue. And we've got that as 12/42. Now this is the point where you should be simplifying. And you can see they're both in the 2 times table, so I can divide both by 2. That's 6 over 21. And hopefully you've also noticed that those are both in the 3s, so that means I can get 2/7 out. Now the second question is asking for the probability that Ben selects 2 different coloured marbles. So that is either probability of red and blue, or, and remember when we've got an or, it's a plus, probability of blue and red. So putting those together, we've got 12/42 plus 12/42. And that, because they've got the same denominator, is now a lot easier to do, is 24 over 42. Remember, this is the point when you can simplify. So first off, they're both even, so I can half both of them, 12 and 21. I've also spotted they're both in the 3 times table again, so that is 4/7. Okay, so hopefully that's helped you with these tree diagrams, okay, and also given you a couple of nice little checks that you can do throughout the question. I recommend that you practice this, especially the conditional probability, and you're really, really careful when you're doing those second probabilities. Okay, well, give it a go. Good luck.